Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about set operations. The first set operation we're going to look at is intersection. The intersection of sets A and B is written A with an upside down U, B. It's the set of elements common to both A and B. So when we say and, we think intersection, which means overlap, what the two sets have in common. In the Venn diagram on the left, we have two sets, A and B, inside of the universal set U. They divide U into four regions. Region 1, that's only in A. Region 2, that's in both A and B. Region 3, that's only in B. And Region 4, which is outside of A and B, but part of the universal set. The intersection of A and B is the shaded region, Region 2. Let's practice using intersection. We're going to find the intersection of the given sets. In part A, we have the set 1, 3, 5, 7, 9 intersected with the set 1, 2, 3, 4, 5, 6. Remember, intersection means overlap or what's in both sets. So I'm going to go through each of the elements in the first set and see if they're in the second set. So 1 is in both sets. 3 is in both sets. 5 is in both sets. 7 is not, and 9 is not. So the intersection of these two sets, what they have in common, is 1, 3, and 5. And if you think about it, we use the word intersection every day. When we're driving around, we say that where two streets meet is the intersection. It's the overlap or what the two streets have in common. All right, in part B, we have the intersection of the set 2, 4, 6 with the empty set. So what did these two sets have in common? Well, if you think about it logically, looking at each element one at a time, 2 is not in the empty set, 4 is not in the empty set, and 6 is not in the empty set. So none of these elements are in both sets. So the intersection is also the empty set. And that's true when you intersect any set, no matter if I tell you what's in the set or not. If I say, what's the intersection of A with the empty set, you would say the empty set, because it can't possibly have anything in common. Now let's talk about union. The union of sets A and B is written AUB, and it's the set of elements belonging to either of the sets. So if it's in A, we include it in the union. If it's in B, we include it in the union. And if it's in both, we include it in the union as well. So on the left, we have a Venn diagram representing A union B. You see how all of the regions which are part of A or B or both are shaded? That's because union means or. It means put everything together into one big set. So we're going to include regions 1, 2, and 3 in the union. Let's use the union operation with these sets. For part A, we have 1, 3, 5, 7, 9 union with 1, 2, 3, 4, 5, 6. One way to find a union, since you're going to put everything together into one big set, is to first copy down all of the elements from the first set. 1, 3, 5, 7, 9. Then you go through and add in any additional elements that were missing from the second set. We already have a 1, we need a 2. We already have a 3, we need a 4. We already have a 5, we need a 6. You don't have to write any of the elements twice, in other words. How about the union of 2, 4, 6 with the empty set? We're going to use the same technique. We're going to write down each of the elements from the first set, and then we're going to look at the second set and see what we have to add. But remember, the empty set has nothing in it, so there's nothing more to add. So when you union a set A with the empty set, you get back exactly the set A. It hasn't been changed at all. And that happens no matter what set A you're talking about. The third set operation we're going to look at is a complement. In this diagram, the region inside of U but outside of the circle A is called A complement, or the complement of A. It contains all the elements that are not in A. So not in a set means it's in the complement. In this case, we're looking at a Venn diagram that only has one set in it. So it only has two regions. A, the part inside the circle, and then the shaded region outside of A, which is region 2, which we're calling a complement. So the three set operations that we're going to use are intersection, union, and complement. Consider this scenario. U, the universal set, contains the letters A through H. A is the set of letters A, B, C, E, H. B is the set of letters C, E, G. And C is the set of letters A, C, D, G, E. So we're going to find the various combinations of set operations, starting with A, B complement. So in part A here, we're looking for B complement. So the way I like to work these problems is I like to replace the capital letter that represents the set with the actual elements it contains. So set B contains C, E, and G. Now we want the complement of that set, which means we look at U and we want everything that's not in B. So you can think of removing C, E, and G from the set U, and what we're left with is a set containing A, B, D, F, and H. Now let's look at part B. For part B, we're looking at A being intersected with B complement. And there's a sort of an order of operations with sets and set operations. And the complement, when the complement is being applied to an individual set, that's going to come first before you do the intersection. So keep that in mind as we work through the problem. That complement's going to happen before the intersection. But first I'm going to replace A with what it's equal to, which is the set A, B, C, E, H. And then I'm going to replace B with what it's equal to, which is C, E, G. And we want the complement of that. And I have to do that complement first. So as we saw a minute ago, the complement of that set involves removing the letters C, E, and G from the universal set. I'm just going to copy the A, B, C, E, H down each step. And here I'm going to replace C, E, G complement with what that's equal to, which is A, B, D, F, H. And now I'm going to find the intersection of these two sets. Remember what intersection means? It means and. It means the overlap. So what is in the intersection of these two sets? Well, A is, and B is, C is not. I forgot to write B. There we go. C is not, E is not, and H is. So A, B, and H are in the intersection of these two sets. So that would be your answer. Now let's compare that to part C. Part C asks us to find A intersect B in parentheses and then complement. These parentheses, just like in algebra, tell us to work that operation first. So we would do the intersection before the complement in this case. So I'm going to copy down my set. Set A is A, B, C, E, H. And we're going to intersect that with B, which contains C, E, and G. And then after we do that, we're going to find the complement. So what do these two sets have in common? Intersection means overlap. So they have C in common and they have E in common, and that's it. So we're just going to have C, comma, E. We don't need the parentheses anymore because we already completed the operation intersection. But now we're left with the complement. So in this case, we have to remove C and E only from the universal set U. So I'm just gonna erase it so we can start over here. So we're going to just take out C and E and see what's left. What's left is A, B, D, F, G, and H. So you see we got a very different answer from what we got in part B. The order in which you perform these set operations really makes a difference. All right, now let's try the last one. Part D says we want B union with C intersect A. So again, the parentheses are telling us what to do first. This time I'm going to leave B written there for just a minute because this problem could get a little lengthy. I want it to fit on the slide. So I'm going to replace C with what it's equal to, A, C, D, G, E. Intersect, I'm going to replace A with A, B, C, E, H. Okay, and I'm going to do what's in the parentheses first, which is the intersection. So what do these two have in common? They have an A in common. They have, what else? An E in common. And let's see, a C in common. And that's it. D is not in that set. B and H are not in the other set. So A, E, and C are the only elements they have in common. And we need to union that with B. But what is B equal to? B is equal to C, E, G. And we're unioning that with A, E, C, which means put it all together into one big set. So I'm going to use the technique of copying down the elements of the first set and then adding to it whatever's missing in the second set. Well, in the second set we have an A, which we don't have yet, but then we already had an E and we already had a C. So this is the union, and we're done. Now the same technique that we just used can also be used to shade regions of a Venn diagram. Here we have a Venn diagram of 3 sets. And a standard Venn diagram of 3 sets has 8 different regions. So if you're asked to use set operations to shade a particular region, I recommend that you number the regions. 1, 2, 3, 4, 5, 6, 7, 8. It really doesn't matter which one you put which number in. These numbers are just there to help us keep track of the set operations. So then we could say, well, our set U contains all the numbers from 1 to 8. So U is the set 1, 2, 3, 4, 5, 6, 7, and 8. And for example, the set B contains the regions 2, 3, 5, and 6. So I'm going to pretend like those are actual elements of the set, just so that I can keep track of which regions are part of which set. So in part A, when we're asked to find B complement, what we're really doing is just removing B from the set U. So we're finding the complement of 2, 3, 5, 6. So we're going to take away 2, 3, 5, and 6 from the set U, and what is left? 1, 4, 7, and 8. So that would be B complement. So what that means is that, now that's not our answer because we were asked to give our answer as a shaded region, but it tells us which regions to shade. So we have to shade region 1, region 4, region 7, and region 8. Now this is not the only way to work this problem. There's another way, which is just to think of B complement meaning everything that's not in B. And you'll see that we get the same result. B is the only part that's not shaded. We shaded everything that's not in B. Let's take a look at another one. So we already did that one. Now we're going to do A intersect B complement. So I've written down which regions are in which sets. And now I'm going to write down A intersect B complement. And I'm going to replace them with what they're equal to. So instead of A, I'm going to write 1, 2, 4, 5. Instead of B, I'm going to write 2, 3, 5, 6. And we're looking for the complement. Now remember, we have to do the complement first, which means removing 2, 3, 5, and 6 from the universal set. So then we're going to have our set A intersected with 1, 4, 7, and 8. So intersection means and, anything that's in both sets. In other words, the overlap. 1 is in both sets, and 4 is in both sets, but nothing else. So that means that we need to shade regions 1 and 4. Let's look at another one. How about A intersect B complement? So I've jotted down the universal set and A and B, and now we're going to work on A intersect B complement. But notice that the complement is on the parenthesis, not on the B. So we're going to do the intersection, the inside of the parentheses first. So inside of the parentheses, we have A intersect B. So that's 1, 2, 4, 5, intersect 2, 3, 5, 6. And then after we do that, we're going to find the complement. The intersection or overlap of these two sets contains just 2 and 5. Those are the only two elements in common. And we need to find the complement of that. Actually, you don't need the parentheses. Let's go ahead and erase those, because we've already done the intersection operation that it was indicating should be done first. And now we're going to find the complement by just removing the 2 and the 5 from the universal set. So that's going to leave us with 1, 3, 4, 6, 7, 8. So those are the regions we need to shade, which is basically everything except for 2, 5. Okay, now another way of doing this would have been at the beginning to say, okay, I want the complement of A intersect B. So I want everything except A intersect B, everything that's not the overlap. The overlap of A and B is this little football shaped piece right here, and then just shade everything else. Everything that's not in the overlap. Okay, let's do the last one. We've done the first 3. Now we're going to do B union C intersect A. For this one, we don't need the universal set U. We just need to know A, B, and C. So I've written down those sets, and now we're going to find B union with C intersect A. So the parentheses are telling us to find the intersection of C and A first. So I'm going to write B union, and then we have 4, 5, 6, 7. Whoops, make sure to use the proper notation. So you have to have curvy set brackets around your sets. 4, 5, 6, 7 intersected with 1, 2, 4, 5. So we're looking for the overlap here. These two sets have 4 and 5 in common. So we have B union with 4, 5. So B is the set 2, 3, 5, 6. And we're going to union that with 4, 5. That means put it all together into one big set. So that's going to give us 2, 3, 4, 5, 6. So now those are the regions that we need to shade. 2, 3, 4, 5, and 6. Now let's see if this makes sense, what we have shaded here. So what I mean by that is, what was this saying in words? This was saying we wanted everything in B, or everything that's in either in B or in both C and A. Okay, so everything in B would be the part that's in the circle B, which is here. And then what's in both C and A? Well, that's the overlap, the football shaped piece here. So what we've done is we've taken anything that's in B or in the intersection of C and A and put it together into one big set. So that makes sense. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. If you have any questions, please post them in the comment section below.